We're talking about transformations of quadratic functions in vertex form, and we want to describe transformations of quadratic functions, write transformation of quadratic functions. So here we have an example in front of us. Describe the transformation of the parent function to the functions represented below. Then graph both functions. Let f of x represent the parent function. So here we have f of x, and the parent function we represent by the equation x squared. So f of x equals x squared. And we can see right down here that we can pick some values to substitute into that equation. So when I substitute those values in, 0, 1, and 2 are always going to be good ones to pick. So 0 squared is 0, 1 squared is 1, and 2 squared is 4. So I can use my graph over here, and I can plot those points. So 0, 1, 1, and 2, 1, 2, 3, 4. Okay, so I have those graphed. Now the nice thing about a parabola is if I graph one side and I know where the line of symmetry is, I can graph the other side. So I can see right here is the line of symmetry. And so what happens is all I do is I take this point and flip it over the line of symmetry. So over one more, over 2, 1, 2, over 2 more, 1, 2. Now I have a pretty good graph. And actually I'm going to pick one more point in order to get a really good graph. So I'm going to pick the point 3. So 3 squared is 9. So that's my y value there is 9. So over 3, 1, 2, 3, up 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then right away I know that I can flip it over the y-axis. 1, 2, 3, 1, 2, 3. So this is the parent function. We have that one graphed. All right. Now we can look at g of x. G of x equals x minus 3 quantity squared. And there's one way that we can do this. We can either, there's two ways we can do it. We can substitute points directly in and just calculate what it's going to be. And that's perfectly okay. So I would pick 0, 1. I would try to pick values that would make this be 0. So in this case, what would make this become 0? Let's pick 3. 3 minus 3 squared. And then let's just keep working from there. 4 minus 3 squared. 5 minus 3 squared. And 6 minus 3 squared. So basically, we picked the points 3, 4, 5, and 6, and we want to see what's going to happen. 3 minus 3 is 0 squared. That is still 0. 4 minus 3 is 1. 1 squared is still 1. 5 minus 3 is 2. 2 squared is 4. And 6 minus 3 is 3. Squared is 9. So we can plot those points there. So we have the points of 3, 0, 1, 2, 3, 4, 1, over 4 up 1, 5, 4, so over 5 up 4, 1, 2, 3, 4, and over 6 up 9, so over 6 up 9, that's going to be all the way up to here. Now if we notice, all these points are shifted over to the right 3. 1, 2, 3, 1, 2, 3, 1, 2, 3. So basically we've taken this whole graph, we just shifted it to the right. So if we notice that right away, we could take the parent function and we could just shift all the points to the right, and then we have it. So again, the nice thing about a quadratic function is if we know the axis of symmetry, which in this case we do because we know where the vertex is located, if we know the axis of symmetry, then we can just flip all the points over that. So over 2, 1, 2, 1, 2. So we got a new point there. 1, 2, and 1, 2, 3, 1, 2, 3. And we can graph that side. So then we have one more to go. We have h of x. And again, we could substitute values in for h of x to figure out where it needs to be. And I'm gonna do partially that and also do a little bit of a scale factor. So I'm going to do this one in 2 steps. So what I'm going to do is I'm just going to take the parent function and I'm going to pick values that will work. So in this case, we're still going to pick 3, 4, 5, and 6 for our x values. 3, 4, 5, and 6. But this time, we're going to have to do this in 2 steps. So we're going to have to do the scale factor, or we're going to have to do the inside and the scale factor, and then drop it down. So 1/2 times 3. Oh, we have to flip this around. This has to be minus. These have to be -3. I have to graph the other side. So I have to make these minus because we have a plus sign in there. -3, -4, -5, and -6. Because this plus sign is here, so +3. So we want to make that become 0. So -3 plus 0, or -3 plus 3 is 0. 0 squared is 0 times 1/2 is still 0. So this part is equal to 0. And then at the end, we have to subtract 5. So 0 minus 5, that becomes -5. Next one we have is 1/2 times -3 times -4 plus 3 squared. So -4 plus 3 is -1. Squared is +1 times 1/2. That's equal to 1/2. 1/2 minus 5, that's -4.5. Then we have 1/2 times -5 plus 3 squared. -5 plus 3, that's -2. Squared, that's 4 times 1/2, that's equal to 2. That's equal to 2. Oh, we forgot, subtract 5. So 2 minus 5 is -3. And we can do one more. 1/2 times -6 plus 3, and then squared. So -6 plus 3 is 3. -3 squared is 9. 1/2, that's equal to 4.5. Minus 5, that's equal to -1/2. And then we can plot those points. So -3, 1, 2, 3, -5, 1, 2, 3, 4, 5. -4, -4.5. So 1, 2, 3, 4. 1, 2, 3, 4.5. So a little bit between there. And -5, -3. 1, 2, 3, 4, 5. 1, 2, 3. And -6. 1, 2, 3, 4, 5, 6. -1/2. And remember, we have our line of symmetry. So once we know where the vertex is, then we can just flip the points over the line of symmetry. So even though it's up here on the half, if I go over 1, that point should be right there. If I go over 2, 1, 2, 1, 2, and over 3, 1, 2, 3, 1, 2, 3. Then I can graph that parabola pretty well right there. And that's the final parabola that we have. And we'll take a look at this in a little bit different view. If we notice before we go there, the vertex here is -3, -5. Remember, the h is backwards, so even though it says +3, when we graph it, it becomes -3. So -3, -5. The vertex here, if we look at this one, it was 3, 0, right? So 3, 0. And if we notice, there's no k value. So really that's like adding 0 there. And for the parent function, the vertex is 0, 0. So when we're working with the vertex value or the vertex form of the quadratic function, it's really important to know where those are, where the vertex is. And we can take a look at the graph. Here we have the parent function, and we can see that the vertex is 0, 0. When we turn on the next function, y equals x minus 3 quantity squared, we see that the graph shifts to the right, 3, 1, 2, 3, and we notice that the vertex there is 3, 0. And then if we click on the next one, what's going to happen is the graph, I actually have to change this to a plus sign. Click on the next one, and the vertex shifted to the left 3, and then down 5, -3, 5, -3, -5. And the last one, the one that we graphed last, so I have to switch that to negative or to a positive. As we can see there, the vertex is still the same. The vertex hasn't changed between these two functions. Negative or plus 3, the vertex is -3, -5. The vertex here is -3, -5. And then we add that a value of 1/2. So what that does is it flattens it out away from what the parent function was before.